Previously on Chemistry Z, our heroes discovered how to order metals in terms of their observable reactivity with water and acids. And just when they found the ancient ores in which to extract these metals from, they were attacked by a past paper question on half equations. But by recalling the wisdom from the ancient specification, our heroes were able to murk that past paper question and collect all the 3 marks. And now, our heroes have made their way to the core of the chemical battleground and have entered the layer of neutralization. Will our heroes be able to describe the different salts that are made, or will they be neutralized by the challenge themselves? Find out in today's exciting episode of Chemistry Z. Here is the retrieval grid for this lesson. The further to the right the question is, the further back in time you have to retrieve the information. And also notice that you gain more points for the questions that are harder to retrieve. Pause the video and see how many of the 12 marks you can get. Remember that oil rig, oxidation is loss and therefore reduction is gain. That's what oil rig means, and we're talking about electrons, okay? Mendeleev left gaps in his periodic table for undiscovered elements. The alpha scattering experiment discovered the nucleus. The malaria pathogen is a protist pathogen, okay? It's a protist. And finally, antibodies are produced by white blood cells. Let's look at what makes something an acid. Here are 3 acids. What makes them acidic? What do you see that they have in common? Pause the video and try and work that out. It's the hydrogen. This doesn't mean that anything with hydrogen is acidic. For example, hydrocarbons are not acidic, even though they've got bare hydrogens, but carboxylic acids are. You don't need to worry about why, but you can comment below if you can guess what these 4 acidic compounds have in common that the hydrocarbon doesn't. So we can define an acid as a substance that produces hydrogen ions when added to water. In this example, hydrogen chloride dissolved in water forms hydrogen ions and chloride ions. Remember that AQ means aqueous, dissolved in water, aqua. This is what that would look like. We have the hydrogen ions produced, so it is acidic. When a substance splits into ions, we call it dissociation or ionization. In reality, we have water particles in between the ions allowing them to move, but I didn't want to make this bit look too complicated, okay? Let's look at another example. Hydrogen fluoride.
You see, hydrofluoric acid won't eat through plastic. It will, however, dissolve metal.
This becomes hydrofluoric acid when dissolved in water. Look carefully at the acids. Which one is stronger? Pause the video and answer the question. It's the hydrofluoric acid. That is because more hydrogen ions are dissociated. The left only has 3 hydrogen ions that are free to move around, but the right hand side has 4 hydrogen ions that are free to move around. Remember, it is all about the amount of hydrogen ions that you have floating around in your solution. That's what makes something a strong acid. Alkalis, on the other hand, produce hydroxide ions when added to water. Sodium hydroxide will form hydroxide ions and sodium ions. The stronger the alkali is, the easier it is for those hydroxide ions to dissociate. Therefore, the more hydroxide ions you have, the more alkaline your solution is. Very similar to acids, the more hydrogen ions you have, the more acidic it is. Now let's look at pH. This number shows you how strongly acidic or alkaline a substance actually is. Associated with the pH is the pH scale, and looking at the substances below, we can see that the lower the pH, the more acidic the substance is. Conversely, the higher the pH is, the more alkaline the substance becomes.
Oh my god! Wow! Oh my god!
pH 7 is neutral. I'll explain why in a bit. The colors that we get here are from a universal indicator. Universal indicator is a mixture of dyes that turn a specific color at a specific pH. But with some pH, it can be hard to tell the differences. So to get a more accurate figure, to get a quantitative figure of this, to get numbers, we use a pH probe or a pH meter. This gives you pH even in decimals. The next bit is for you lot doing the higher paper. Here is the pH scale once again, and I'm going to partially fill out the concentrations of hydrogen ions in each solution.
Jesus Christ.
I know this looks a little bit crazy now, but there is a method to this madness. Just pause the video here and try and answer these challenge questions. When we increase the pH number, notice that we are decreasing the concentration of hydrogen ions. The number gets even smaller. For the next question, you had to crack the conversion of pH into hydrogen ions. When the pH is 1, the concentration is 0.10 moles per decimeter cubed. When the pH is 2, the concentration is 0.010 moles per decimeter cubed. The pH number is proportional to the number of zeros in front of your 1. pH 1 has 1 0 in front of it. pH 2 has 2 zeros in front of it. We then first have to find out what pH black coffee is. And we can see that it's pH 5. So we have 5 zeros in front of our 1. To convert this into standard form, we need to first write the first and second significant numbers and separate them by the decimal point. In this case, that would be 1 and 0 to give us 1.0, okay? We always use base 10, so this next bit is always the same, times 10. It's always going to be times 10, especially in GCSE. The next bit is the number of places we had to move our decimal to get that number. And for this, it was 1, 2, 3, 4, 5. Numbers smaller than 1 have a negative. So this is -5. That means the full thing is 1.0 times 10 to the minus 5 moles per decimeter cubed. Now this brings everything together. The stronger the acid, the more hydrogen ions that are dissociated. That means that you have a higher concentration of hydrogen ions, which means your pH is lower.
Okay.
I've got a list of strong and weak acids now. Pause the video and see if you can arrange them into their correct groups. The strong acids are the nitric, sulfuric and hydrochloric acids. The weak ones are the ethanoic acid, you find it in vinegar, citric acid, which is in fruits, and carbonic acids as well. Here's how you write the reaction for strong and weak acids. First, remember that you have to dissolve them in water. This gives us aqueous ions, but most importantly, those hydrogen ions that are free to make it acidic. Strong acids like hydrochloric acid and hydrofluoric acid completely ionize. That means they produce a lot of hydrogen ions. Weak acids, on the other hand, have pHs higher than 2 and are shown with a reversible arrow. This tells us that they produce hydrogen ions, but their reaction can easily go backwards. We then say that these are partially ionizing. Again, this all just means that the stronger the acid, the more hydrogen ions are available to react. We're now going to look at the differences between bases and alkalis. I've got 2 bases and 2 alkalis over here. On the left hand, we have the pure solid, and on the right, we have what they look like when we've added water. This image from BBC Bitesize will help you answer this challenge question. Pause the video and decide which of these 4 are alkali. We see that alkalis are soluble bases. So the ones that are dissolving, that dissolve properly, so when see no precipitate inside it, it's not cloudy, those ones are alkali. So sodium hydroxide and potassium hydroxide are the alkalis. They give us a clear solution with no suspended particles or precipitates. When a metal reacts with an acid, it forms a salt and hydrogen. I've colored the different substances so we can clock where the different atoms are coming from. The hydrogen is in blue and that comes from the acid. So the metal, which is in purple, has taken the place of the hydrogen in the acid. This is what a salt actually is. A salt is a compound formed when the hydrogen of an acid is replaced by a metal ion. Look at this example. The metal is sodium and the acid is hydrochloric acid. This makes the salt sodium chloride and hydrogen. You may remember from this video that this is an example of a displacement reaction. Salts are named in 2 parts. The first part of the name is either a metal or ammonia, and the second part of the name comes from the acid. When you see the surname of a salt, you already know the acid that was used to form it. So hydrochloric acid forms a metal chloride. Think carefully about these salts now. What acid made them? Sulfates are created by sulfuric acid and nitrates are created by nitric acid. Before we move on, let's look at the higher paper half equation. Here is the symbol equation. At the moment, it isn't balanced. Check out this video on balancing equation to see why this is the balanced equation. I'm not going to go through it here. Then we split up our ions into this equation here.
What is this one again? Johnson, so what is this one again?
We're only splitting up the ones that are aqueous, okay? See that the sodium that's solid and the hydrogen that's a gas stay exactly the same.
Stop it.
Look, it ain't that deep. We had 2 lots of hydrochloric acid and 2 lots of sodium chloride. So we've got 2 hydrogen ions and 2 chloride ions on the left hand side, and then 2 sodium ions and 2 chloride ions on the right hand side. Everything else stays the same because they aren't aqueous, as I said before. Now at this stage we need to get rid of our spectator ions. These are the ions that are the same on the left and right hand side of your equation. The sodium has changed and the hydrogen has changed, but the chloride has not changed, so that's our spectator ions. Let's cross that one out. This equation is now an ionic equation. Spend some time now creating the 2 half equations from this ionic equation. If you need a refresher, check out this video here. For sodium, we start with a solid atom and get an aqueous ion. To complete the half equation, we add the electron to the side that has the positive ion. We also have to balance the charge. The positive ion is on the right hand side, so we need our electrons here. Each sodium has a 1+ charge, but we've got 2 sodium ions, so we need 2 electrons, 1 electron going to each 1+ sodium ion. pause the video and do the same for the hydrogen ions. We have two 1+ ions on the left hand side, so we need 2 electrons also on the left hand side. The sodium lost electrons, so that's oxidation, and the hydrogen gained electrons, so that's reduction. Now pause the video and match up the acid and base that made each of these salts. Don't overthink it, it's actually pretty simple. The first salt is copper sulfate, so we need copper ions, and to get the sulfate ions we need sulfuric acid. Then we have calcium chloride, so we need calcium ions, and the chloride ions come from the hydrochloric acid. Finally, we have cobalt chloride, so we need cobalt ions from somewhere. And finally, the nitrate ions come from the nitric acid. I've already covered how to make salts for your required practical in detail in this video, so I'll only give you a brief overview here. First, you gently heat the acid. In this reaction, the base is copper oxide and the acid is sulfuric acid, so you can already work out what salt we're making. You keep adding the base until it's in excess. This means that it isn't dissolving or reacting anymore. Notice the unreacted copper oxide. We need to get rid of this because we don't want that in our pure salt crystals, so we filter it. This gives us a solution of our salt, but again we want salt crystals, so we have to crystallize this solution. We gently heat the solution because the slower the cooling, the larger our crystals. When the solution becomes saturated, the salt crystals start forming. When half of the water is evaporated, stop heating it and leave it in a cool place to cool overnight, and then you get these lovely salt crystals. And there we go, lesson is done.
Fatality.
As I said before, check out the video on the required practicals on making salts so you can have more detail on that. Check out the description to get my flashcards and my revision timetables if you haven't got them yet. Use the description also to skip to wherever you need to go to where you're confused, and I'll catch you guys in a bit.